So in this video, we're going to talk about solving exponential equations. So let's just jump right into it. All right, so I've talked about how to solve basic exponential equations. And no, I do not mean exponential equations that like pumpkin spice lattes, but things that are just a little simpler to solve. So this type of equation, I just want to notice like why this is not basic. So with basic exponential equations, so just to give you an example, if I had something like this, 2 to the x plus 3 equals 8 to the x thirds. So the thing about this equation is I can write this particular side as the same base as this side. So I could rewrite this as 2 to the third to the 3x. So I've talked about these like basic equations in other videos. Now, contrast this to this example. Obviously 2 and 7, there's just no way to make these two numbers equal one another. So let's discuss then what technique you want to use in this case. The first thing that you want to do for an exponential equation like this is you want to take the natural log or the log of each side. So sometimes there's a strategic choice between natural log and log. In this case, it really doesn't matter. It will be obvious when you want to make a strategic choice, so we will discuss that when we get there. So if I take the natural log of each side, what does that allow me to do, my friends? Well, then I can use properties of logarithms to rewrite this, right? So this becomes x plus 3, put parentheses around that, by the way, times the natural log of 2 equals 3x times the natural log of 7. So the whole idea here was that I wanted to solve for x, and now I've gotten rid of x in the exponents, and now it's just like, this is almost like an algebra equation. So the next thing that I want to do is I want to distribute this side out. So I have x natural log of 2 plus 3 natural log of 2 equals 3x natural log of 7. Okay, so at this point, this is just a straight up basic algebraic equation, even though it looks kind of crazy. So here's the deal. Here's an x, here's an x. I want these two terms together on the same side. The term that does not have an x in it, this is just a number, right? So I'm going to subtract this term to the other side. So let me make some space. And so let's see. Let's rewrite this. We'll write 3x natural log of 7. I'll write it on this side. Minus x times the natural log of 2 equals 3 natural log of 2. So I just put the x's together on one side. All right. So now, how do I finish solving for x? This is a pretty standard trick that you use in math. So what I notice is that both of these terms have an x in them, so I can just factor the x out, and in doing that, now I can pretty easily solve for x by just dividing out the stuff I don't want. And you can plug this last part into a calculator if you wish. I personally prefer just to leave the answer in this format because it's more accurate. But there you go. So there's everything that you need to solve for x. Okay, so let's try a few more examples, I guess. All right, so let's start with this example here. So I've got e to the x squared equals 100. All right, so for this example, remember, you have the choice of natural log versus log. So which one do you want to use here? Well, oddly, I'd say like either choice would work. I'm going to use the natural log though because I see that there's an e here. So let's take the natural log of each side. Okay, so in doing that, I can bring the x squared down. But now I notice that this side, this natural log of e, so remember, there's that property that log base a of a equals 1. And remember that the natural log really means log base e of e, so that this is what's happening. So this just equals 1. Okay, so now this whole equation is just x squared equals natural log of 100, and then I can write this, I can use the square root property, write this as plus or minus the square root of the natural log of 100, and there you go. Okay, So sometimes exponential equations can look a little more difficult than they really are. So, all right, let's take a look at B here. It just looks like there's a lot going on, but the reality is that I can use exponent properties to help me with this. So what can I do with the exponents on this side? I can add them. So what I would recommend here is that you take a crack at this, see if you can solve it, and if you get stuck, there's no shame in that, but you'll get more out of this video if you at least try. So give it a try, hit play when you're ready. Okay, so I'm going to go ahead and add the exponents. So I have 2x plus 3x minus 3 equals 5e. And so this will be e to the 5x minus 3 equals 5e. Now what if I wanted to divide both sides by e? You could do that and then subtract 1 from here. Or you could just go ahead and take the natural log of each side. It doesn't really matter. So let's see. Why don't we, I'm actually going to go ahead and divide by e. I just want to make this as few things to write down as possible. So what that's going to do is I'm going to just subtract 1 more from here to get rid of this e. So this becomes e to the 5x minus 4 now equals 5. Okay, so from here, let me make some space. And once again, it's probably in our best interest to use the natural log. So I have natural log of e to the 5x minus 4 equals the natural log of 5. So now I can bring down the exponent. And so once again, the natural log of e, this just equals 1. So I have 5x minus 4 equals the natural log of 5. And so this is a nice simple equation to solve, right? So let me clear some space. All right, so first I can add 4 to each side, and then I can divide everything by 5. So I have x is going to be equal to the natural log of 5 plus 4 over 5. And maybe I want to just put that 5 in parentheses so that it's clear that the 4 does not belong with the natural log. Okay, so continuing our exploration of exponential equations. So I just want to show you all the different ways that these can really pop up. Okay, so in this case, notice I've got, here's my exponential, 2 to the x plus 2. I have all this other noise around it. So and I'm still trying to solve for x, right? So the first thing that I want to do is I want to just try to get rid of all this other noise so I can just get the exponential by itself. So to do that, first I'm going to subtract 6. So I have 3 to the 2x plus 2 equals 99. And then I can divide both sides by 3. And now I have just 2 to the x plus 2 equals 33. Okay, and so here now I can go ahead and actually solve this. So I'm still going to use log or natural log. I'm going to use the same strategy as before. So what I would recommend is that you pause the video here, give this a try, and then hit play when you think you've got it. I'm going to clear some space. All right, so I'm just going to take the natural log of both sides, and then I'll bring down the exponent, and then I can distribute Okay, so I need to clear a little space. All right, so now remember, I'm just trying to solve for x. There's an x here, so just anything that doesn't have an x, like this 2 natural log of 2, I'll just send it to the other side. So let's see, this is the natural log of 33 minus 2 natural log of 2, and then divide everything by the natural log of 2. So I have x equals the natural log of 33 minus 2 natural log of 2 over the natural log of 2. Do not fall into the trap of saying, oh, and then I can cancel out the natural log of 2. No, you cannot. You can only do that if every term here has a natural log of 2, which is not true. If you really want to cancel, you can separate this into 2 separate fractions and then make a cancellation. So what I'm saying, I'll just clear a little space to show you. You can write this as, x equals natural log of 33 over the natural log of 2 minus 2 natural log of 2 over the natural log of 2. now I can cancel those out to get x equals natural log of 33 over a natural log of 2 minus 2. So these are equivalent, but this is the only way you can do the cancellation, okay? Now, something that can happen with exponential equations is you can actually have, you can combine a variety of techniques to solve them. So I bring that up because I've got e to the 2x minus 2e to the x minus 15 equals 0. So the thing I notice with this is I've got e to the x and e to the 2x. This is double the first exponent. When that happens, you have something that is like pseudo-quadratic. That's how I think of it. And you can use substitution to actually help you with this. We have to think a little bit more creatively. I can't just start taking natural logs because I have e to the 2x and e to the x. Okay, so I'm going to have e to the x. I'm going to set it equal to y. And then my y squared will be equal to e to the 2x. So you can always set this up whenever you have one exponent and then double that exponent. If this were x and 3x, then we couldn't do it. But if it's x and 2x, we can. All right, so now I'm going to make some substitutions here. So where I had e to the 2x, I'm going to write this as y squared minus 2y minus 15 equals 0. And in this format, I say, oh, I can totes my goats factor this. And so this will factor y, let's see, y minus 5, y plus 3 equals 0. And then I'm just going about my day here saying, oh, that equals y equals 5 and y equals negative 3. Not done though, right? So I have to replace y now with that original thing I made the replacement with. So this becomes now e to the x equals 5 and e to the x equals negative 3. And here, now we have to kind of use our noggins for a moment. All right. Think about how exponents work. Is there any value of e to the x? E is a positive number, right? Is there any value that I can raise it to where it will equal a negative number? No, I can't, right? This just can't happen. You can't have a positive number, raise it to some exponent, and have it equal a negative number. It's just not a thing. So this is not an actual possibility. It's not a solution. So we only need to focus on what do we do with e to the x equals 5. So let me clear some space. And let's look at our friend e to the x equals 5. So now this is actually where I have to use those techniques that we've been talking about in this video. So I didn't think I had to use it, and now actually I see that I do. So to finish solving for x, I need to take, oops, let me change my pen color. I need to change this to natural log of e to the x equals the natural log of 5. Bring the x down, so I get x natural log of e equals the natural log of 5. And then since the natural log of e equals 1. This is just x equals the natural log of 5. And now we have the lone solution. Okay, so I have one more example here, very similar idea. So I've got 3 to the 2x plus 2 times 3 to the x equals 24. So similar deal with the exponents, right? I have 3 to the x, 3 to the 2x. So I can make substitutions, y equals 3 to the x. There's a hint. The other thing I just want to state here is that you're going to want to subtract off the 24. So this is a very similar trick to what we did in the last one. And math is not a spectator sport. You will get the most out of this if you can pause here, give this a try. And even if you get stuck, the explanation will make 10 times more sense to you if you actually give it a try. So try it, hit play when you're ready. Okay, so like I said, I want to just rewrite this for a moment. Like so. Oops, 24 equals 0. And then I'm going to make some substitutions. So I'm going to set y equal to 3 to the x and y squared equal to 3 to the 2x. So that I can rewrite this expression as y squared plus 2y minus, y squared plus 2y minus 24 equals 0. Okay, cool. So now, does it factor? Well, let's see, it factors y and y. So two things that multiply to negative 24, but add to negative 2. That would be plus 6 minus 4. Cool. So I have y equals negative 6 and y equals 4. And now I have to make my substitutions. So remember, y was equal to 3 to the x. So this is 3 to the x equals negative 6 and 3 to the x equals 4. And now we're saying, hey, 3 to the negative x, there's no way that that can equal a negative number, right? So this does not make any sense. It just can't happen. So we're just going to focus on 3 to the x. Okay, so let's clear some space. And so once again, so I can just take, I can take the natural log of each side. So I have x natural log of 3 equals natural log of 4. So then I get that x will equal the natural log of 4 divided by the natural log of 3. Okay, and so that kind of runs the gamut of different types of equations with exponentials that you'll see. Hopefully that was helpful. Consider giving the video a like if you thought it was helpful, and I will talk to you guys in the next video.